Okay, so hello everyone, this is Akshay here, and let us continue with the today's GFG POTD suite. Today's question name is the predict the column. So we have been given a matrix, 2D matrix of n cross n consisting of zeros and 1. The task is that we need to find a column with the maximum number of zeros. If there are more than one column which has the same number of maximum zeros, then we need to return the first one, right? So in this case you can clearly see the first column has two zeros, right? This one and this one. Second column has again two zeros, and third column has only one zero. So what is the maximum number of zeros? So these two are the maximum number of, or set the maximum count of the zeros, right? So if two columns or multiple columns have the same maximum values, then you need to return the first one. What do you mean by first one? That we are traversing from the left hand side to the right hand side. So this is the first column that we encountered with the maximum count of 0. So what is the column number here? It is 0. So your final answer would be 0, right? That is what there in our first test case, correct? So what we can do this, how we can solve this question? So first of all, it's again a matrix traversal question. So first of all, we will write down the need, and we'll try to convert our need diagram into the pseudocode, right? So we want to iterate first of all in all three columns, right? In all three columns. So for this thing, that is for 0, 1 and 2, I can definitely write a for loop that is starting from I equals to 0 to I less than n, I plus plus, right? Now I need to traverse downwards, right? First this, and then I have to go here and then this down, right? So first, then second, and then third. This is how I need to traverse to have the count of 0 in the first column and then in the respective ones, right? So definitely, how are we proceeding? So it is 0, 1 and 2 again the indexes, right? So we'll be going to have a for loop that is starting from j equals to 0 to j less than n and j plus plus, right? So the first column has the 0 constant, right? So we will have a matrix, we will have the index values. So I would be here, right? Because for each and every year we are considering one column, right? And then what are we visiting? We are first visiting 0, 0, then we are visiting 1, 0, and then we are visiting 2, 0, right? After we are done with this, then we are visiting 0, 1, then again 1, 1 and 2, 1, right? So you can clearly see that these are the constant values. So that's why this represents here I, and these values which are changing going from 0 to n, this will be represented by j, right? Okay, so what we next to do now, this nested for loop is handling the traversal of all the column elements. So we will have a count zeros equals to 0, right? And we will check if matrix of 5 equals to 0. I will just say count 0 plus plus, right? And after this nested for loop, I will just check. I will have two more variables, let's say answer, which is pointing to 0, and then we have the index, which is pointing to -1, right? I will check if my previous answer is nothing but the count, the maximum count we want to have for the zeros. I will check if my answer is less than my current count of zeros, right? Then I will update my answer, that answer is equals to count zeros, and similarly I have to update my index as well. So idx is nothing but I, because this was the column, right? We'll be going each and every column traversal. So that's it. This would be closed here. So that would be a pseudocode for this question. Please try to code this approach by yourself, and then we can move ahead with the Java and C++ solution. So I hope you were able to code it by yourself. So that's the code in Java. The same thing we have discussed in pseudocode and in the dry run. So what is the time and space complexity? Since we are using two nested for loop, which is going from 0 to n, so definitely the time complexity is O of n square. Considering the constraint, you can clearly see n is 10 power 3, and we are using n square. So squaring 10 power 3 will give you 10 power 6, which is less than 10 power 8, and that is why our solution got submitted. So we have done the today's streak question as well. What is the space complexity? Since we are not using any space except some variables, so it will be O of 1. Let us switch back to the C++ code. Again, that's the same as we have done in Java, dry code, and dry run and pseudocode, right? Let's just hit the submit button for this code as well. And yes, so there is one more additional information for you guys. Today I had a session with my juniors of my college, right, regarding the DSA placement. So they had a bunch of questions. Like they were second year students, so they were asking how when we should study for DSA, which is more important, DSA and development and all sorts of things. So I have requested the recording of from the faculty advisor who has invited me to this session as a guest, as the orator. So once I get the recording from them, I will upload that particular recording in my channel as well, so that many of you who have the same question could be benefited, right? So yes, till then, let us meet in the tomorrow's GFG Pure Data Streak. Till then, keep learning, keep going. Bye bye, and take care.